You know the name, right? The wild hair, that face. It just screams genius. Albert Einstein. But how much do you really know about the man? Beyond the image, beyond the science we sort of vaguely remember.
Exactly. There's the icon, and then there's the actual person and the revolutionary thinking.
So today, that's what we're doing. We're taking a deep dive into a bunch of sources that really shed light on Einstein's incredible life, his his groundbreaking mind, obviously, and the achievements that just completely reshaped how we see the universe.
Mm-hmm.
Our mission here is to pull out the key nuggets, go a bit beyond the usual stuff, maybe find some surprising facts, some insights, so you can walk away feeling like you really get Einstein a bit more.
And appreciate just how extraordinary he was, yeah.
Okay, so let's unpack this journey. Albert Einstein, born in Ulm, Germany, March 1879, and right from the start, it's a bit surprising. Like, apparently, he didn't even talk until he was 5.
Yeah, it's incredible to think about, isn't it? That this mind that would unravel the cosmos started so quietly, verbally at least. But what's often highlighted, and I think it's fascinating, is this moment when he was 5. He was sick in bed, and his dad gave him a compass.
Ah, the compass story.
And he was just amazed, completely mesmerized, that the needle always pointed north. Didn't matter how he turned the compass case.
Huh.
And that, he said, made a deep and lasting impression of curiosity. It made him realize, like, something deeply hidden had to be behind things.
Wow, that's a huge realization for a 5-year-old.
It really was a
Good.
foundational spark for everything that followed.
It's wild, that simple thing. But, okay, despite that flash of insight, his school years weren't exactly smooth sailing, were they? I read he was like a super creative problem solver, even taught himself calculus before 16.
Differential and integral calculus, yeah, pretty advanced stuff.
But he apparently hated the rote discipline style of his teachers in Munich, so much so that he just dropped out at 15.
Yeah, he did. And that's such a key detail, I think, because it kind of pushes back against the typical genius follows the rules narrative. Here's this brilliant mind mastering complex math on its own, but it just couldn't handle the rigid structure. And because he dropped out, no German school wanted him.
So what did he do?
He had to go to Switzerland. He eventually enrolled in the Swiss Federal Polytechnic School in Zurich.
Yeah.
But even there, his grades were, well, interesting.
How so?
He smashed it in math and physics, obviously.
Yeah.
But he actually failed French, chemistry, and biology.
No way. Failed.
Failed. It just shows that, his brilliance was super specific, not really built for the standard academic checklist.
So after he graduated around 1902, it sounds like things got pretty rough for him. He called it the lowest point of his life.
Yeah, it seems like it was a really tough period. His father's business went bankrupt. He was struggling to make ends meet, support his family. Apparently even got fired from a tutoring job.
Ouch.
Yeah, left him feeling incredibly frustrated. And the really sad part is his father died before Einstein actually, made his big breakthroughs.
Oh, man.
Left him with this enormous sadness, he said, and this feeling of being a failure.
That's tough. It really grounds him, though. Makes him seem, well, human.
Absolutely. Thinking of Einstein feeling like a failure. But it was right around then, during that really hard time, that things started to shift. A friend's father, Marcel Grossman.
Ah, Grossman. Important name.
Very. He recommended Einstein for a job at the Swiss Patent Office in Bern, 1902.
The famous patent office job.
That's the one. It gave him his first steady income. And that stability, that confidence boost, it allowed him to marry Mileva Marriage when he was 24. And that seemingly, mundane job, it turned out to be absolutely pivotal.
Okay, this is where it gets really interesting, isn't it? Because that patent office job, it was like an accidental gift.
Totally unexpected blessing, yeah.
He apparently finished his work analyzing patent applications really quickly.
He got good at boiling things down.
Which left him tons of time to just sit and think. To daydream about that vision that had obsessed him since he was 16. What if you could race alongside a beam of light?
Exactly. And that routine, analyzing patents day in, day out, it actually sharpened his thinking. It forced him to, like you said, strip information down to its absolute core, get to the essence.
A still in itself.
A crucial one, because that intellectual freedom, that space to think, it led directly to 1905, his Annus Mirabilis.
The miracle year?
The miracle year. This still relatively unknown physicist publishes not 1, not 2, but 4 revolutionary papers.
4 in 1 year. That's just insane productivity, especially for someone basically doing it on the side.
It's mind-blowing.
So, okay, what were these huge breakthroughs? What did he give us in 1905?
Well, they fundamentally changed everything. Space, time, matter. laid the groundwork for so much of modern physics.
Okay, break them down for us.
All right, first, the photoelectric effect. He basically proposed that light isn't just a wave, like everyone thought. It also acts like it's made of tiny, localized particles or packets of energy, quanta.
Which we now call photons.
Exactly, photons. So light is both a wave and a particle, which was, a pretty radical idea back then.
Hugely counterintuitive. And that's the one that actually won him the Nobel Prize later on, right? Not relativity.
Correct. It was met with a lot of skepticism initially, but yeah, the 1921 Nobel Prize in Physics was for the photoelectric effect. And it wasn't just theoretical, it laid the foundation for quantum mechanics and, down the line, things like solar cells, lasers, stuff we use constantly.
Okay, that's one. What else?
Second paper, Brownian motion. This was huge because he provided mathematical proof for the existence of atoms and molecules.
Wait, people were still debating if atoms were real in 1905?
Oh yeah, it wasn't universally accepted. He explained the jerky, random movement of particles suspended in a fluid Brownian motion as being caused by collisions with these unseen atoms. And he even showed how you could figure out the size of these atoms from it.
Wow. Okay, so proving atoms exist, changing how we see light. What else did he squeeze into this miracle year?
Well, then came probably the most famous equation in history. EMC5.
Ah, yes. The big one.
The big one, showing the equivalence of mass and energy. Matter can be converted into energy, and energy into matter. This explained where the sun and stars get their immense energy.
From converting mass into energy.
Precisely. And of course, later it became the theoretical basis for nuclear energy and, unfortunately, nuclear weapons.
Okay, 3 down. What was the fourth?
The fourth was special relativity.
The other big one.
Definitely. This theory deals with the relationship between space and time. And it apparently grew out of that daydream he had on a tram in Bern.
The one about racing a light beam?
Sort of. He wondered what would happen if the tram moved away from a clock tower at the speed of light. He realized the clock would appear, frozen, stopped.
Because the light carrying the image of the next tick could never catch up to him?
Basically, yeah. It led him to propose that the speed of light is constant for all observers, regardless of their motion. And the consequences are bizarre. The faster you move through space, the slower you move through time. Time dilation. Length contraction.
Mind-bending stuff. And it completely got rid of the need for that old idea of the luminiferous ether, right? The stuff light was supposed to travel through.
Exactly. It rendered the ether unnecessary. Space and time weren't fixed, absolute backdrops. They were interwoven into space-time and relative to the observer.
He had that great analogy for it, didn't he? Something about a hot stove and a pretty girl.
Yes. Put your hand on a hot stove for a minute, and it seems like an hour. Sit with a pretty girl for an hour, and it seems like a minute. That's relativity. Simple, but effective.
Captures the subjective experience of time, yeah.
But, as revolutionary as special relativity was, Einstein knew it wasn't complete. It had a limitation.
Which was?
It only worked for things moving at a constant speed, uniform motion. It didn't account for acceleration.
Which is, well, pretty much everything in the real universe, right? Planets orbiting, cars speeding up, apples falling.
Exactly. It wasn't suitable for the messy, accelerating reality we live in. And crucially, it didn't include gravity.
So he wasn't done. He kept thinking. Kept doing that Six Fleisch thing his friends talked about, just sitting and pondering for ages.
Prodigious ability to just sit and think. And the story goes, one day, he's looking out his office window, maybe at the patent office, maybe later, and he has this thought experiment.
Another one.
He imagines a man falling from a roof, or maybe in an elevator whose cable has snapped.
Oh, okay. A bit grim.
Maybe. But the point was, during that free fall, the man wouldn't feel his own weight, right? He'd be weightless, just like astronauts in orbit.
Right, like floating.
And this led Einstein to what he called the happiest thought of his life. Maybe gravity isn't a force pulling things down.
But something else entirely.
Exactly. Maybe gravity is actually the effect of mass and energy warping or curving the fabric of space-time itself. Objects aren't being pulled. They're following the curves created by massive objects.
Whoa. Okay, so instead of Newton's idea of gravity as a force acting across distances,
Einstein says mass tells space-time how to curve, and space-time tells mass how to move. It's a geometric effect.
that is a fundamentally different picture of the universe.
Completely. This became the general theory of relativity, developed between about 1907 and 1915. It posits that what we feel as gravity is just us moving through warped space-time. And this new theory could even explain things Newton's couldn't, like tiny anomalies in the orbit of Mercury.
Okay, but, I mean, that sounds incredibly abstract. How on earth do you prove something like space-time itself being curved?
Yeah, that was the challenge. You needed something really massive to create a noticeable curve, something massive enough to bend the path of light passing near it.
The sun.
Like the sun. The idea was if space-time is curved near the sun, then light from distant stars passing close to the sun on its way to Earth should follow that curve. It should look like the star's positions are slightly shifted.
Okay, makes sense. But how do you see stars that are right next to the sun? It's way too bright.
Exactly. You can only do it during one specific event, a total solar eclipse, when the moon conveniently blocks out the sun's glare.
So you needed an eclipse.
You needed an eclipse, and this kicked off a real scientific drama, a race to observe an eclipse and test Einstein's crazy idea.
Sounds exciting. Did it go smoothly?
Oh, not at all initially. The first major attempts in 1914 were just plagued by bad luck and, well, global events.
Like what?
Well, a German astronomer, Erwin Freundly, led an expedition to Crimea. But then World War I broke out. He was arrested as a German spy.
Oh my God, seriously?
Seriously, expedition over, and another American expedition went to Kiev around the same time, but they just got clouded out. Couldn't see a thing.
So total failures. How did Einstein take that?
He was apparently shattered. He was back in Berlin, totally reliant on these astronomers miles away, and it all fell apart. Must have been incredibly frustrating.
I bet. So when did they finally get the evidence?
It took until after the war, in 1919. A British astronomer, Arthur Eddington,
A famous name in astronomy.
huge name, he led expeditions to two locations to observe a total solar eclipse. One went to Brazil, another, led by Eddington himself, went to the island of Principe off the coast of West Africa.
And this time?
This time, despite some technical issues and clouds, Eddington got the photographic plates he needed on Principe. He compared the positions of stars near the sun during the eclipse with photos of the same star field taken at night months earlier.
A moment of truth.
And it was clear. The starlight had bent as it passed the sun. The positions were shifted, and shifted by an amount that matched Einstein's predictions from general relativity, not the older Newtonian prediction.
Wow. He must have been ecstatic.
Eddington was thrilled. When the results were announced back in London, it caused an absolute sensation.
I can imagine. What was the reaction like?
Front page news. The New York Times reported it. The Times in the UK had this massive headline: Revolution in Science New Theory of the Universe, Newtonian Ideas Overthrown.
Newtonian ideas overthrown. That's huge.
It instantly catapulted Einstein from being a famous physicist among scientists to being a global superstar. Maybe the world's first, celebrity scientist.
Yeah.
That iconic image started to form right then.
Amazing. Just overnight fame based on starlight bending. But
Wow.
was everyone convinced? You mentioned World War I earlier. Anti-German sentiment. Did that play a role?
It definitely did. Despite the headlines, there was some backlash. Some scientists remained skeptical, questioned the accuracy of Eddington's measurements.
Hmm?
Eddington himself was even accused by some critics of maybe
Mm,
fudging the figures slightly because he wanted Einstein's theory to be right.
really? Was there any truth to that?
It's complex. There was definitely post-war tension. Eddington was a Quaker and an internationalist who admired Einstein's pacifism, so maybe there was some bias. But subsequent analyses suggest his results were basically sound, if maybe not quite as precise as initially claimed. It really took more expeditions.
For eclipse chasing.
Yep, like a big one led by William Wallace Campbell in Australia in 1922. Meticulously planned. But guess what?
Clouds.
Clouds again. It was incredibly difficult.
Mm.
But over time, with more observations, the evidence solidified. And then, much, much later, we got the ultimate proof. Nearly a century later, in 2015, the detection of gravitational waves by LIGO.
Ah, the ripples in space-time itself.
Exactly. Ripples predicted by general relativity, caused by massive events like black holes merging. Detecting them was undeniable confirmation of Einstein's theory and opened up a completely new way to observe the universe. Just incredible validation.
It really shows the long arc of scientific confirmation sometimes.
Amazing.
Okay, so beyond the physics, which is obviously immense, Einstein was also a really engaged figure in the world, wasn't he? Politically, socially.
Oh, absolutely. It's fascinating, that contrast. You had this mind dedicated to the objective mathematical truths of the universe, but also deeply, passionately engaged with the messy, anxious realities of human life.
He was famously a pacifist, right? Even during World War I.
A committed pacifist, yeah. While many German intellectuals signed this thing called the Manifesto of the 93, basically justifying Germany's war aims.
He refused.
He was one of the very few who refused. Instead, he signed a counter-manifesto, the Manifesto to the Europeans. calling for peace and cooperation. And he was apparently horrified when his own friend, Fritz Haber,
The chemist, Nobel laureate.
that's the one, Haber developed chlorine gas, poison gas used in the trenches, killed and injured thousands. Einstein was appalled. He apparently said something like, "All our supposed technological progress is like an axe in the hands of a pathological criminal."
Wow, strong words. So, given those strong pacifist beliefs, how did things unfold when Hitler and the Nazis rose to power in Germany? He was, well, everything they hated, wasn't he? Famous scientist, Jewish, pacifist.
He was a prime target. Absolutely. When the Nazi took power in 1933, things got dangerous for him very quickly. His books were publicly burned in Berlin.
The infamous book burnings.
Yes. They froze his family's bank account. There was even reportedly a bounty put on his head, 50,000 Reichsmarks.
Good grief, he had to get out.
He did. He was actually visiting the U.S. when Hitler became chancellor. He never went back to Germany. He was briefly given refuge by the Belgian royal family. Can you believe it?
Wow.
But eventually, later in 1933, he moved permanently to the U.S., taking up a position at the Institute for Advanced Study in Princeton, New Jersey.
All right, so he finds refuge in America. But this brings us to a really difficult, complex part of his story, doesn't it? The atomic bomb. How does a lifelong pacifist end up connected to that?
It's a profound dilemma. The key moment was in 1938-39. Scientists in Berlin, Otto Hahn and Lise Meitner, among others, figured out nuclear fission, how to split uranium atoms, releasing energy.
Right, the scientific basis for a bomb.
Exactly. And another physicist, Leo Szilard, who had also fled Europe, became deeply concerned that Nazi Germany might be racing to build an atomic weapon based on this discovery.
A terrifying prospect.
Absolutely terrifying. So Szilard, knowing Einstein's fame and influence, convinced him, along with other concerned scientists, to sign a letter to President Franklin D. Roosevelt. This was in August 1939.
The famous Einstein letter.
That's the one. It warned Roosevelt about the possibility of extremely powerful bombs of a new type and urged the U.S. government to start its own nuclear research program, basically to get there before the Nazis did. Einstein's Ipsifor, of course, explained the potential energy release, though the letter didn't detail how to build a bomb.
And that letter directly led to?
It directly prompted the creation of the Manhattan Project, the U.S. effort to build the atomic bomb.
So Einstein, the pacifist, kicks off the nuclear arms race in a way. How did he reconcile that?
It weighed on him heavily. He later wrote that he did not see any other way out. The fear of Hitler getting the bomb first was just too great. But then, August 1945 happens.
Hiroshima and Nagasaki.
The U.S. drops 2 atomic bombs on Japan, over 200,000 people killed, mostly civilians. It's just a brutal illustration of how pure science can lead to utterly devastating real-world consequences. Einstein was deeply troubled by it for the rest of his life.
I can only imagine. But even in America, he didn't just retreat into physics, did he? He used his platform.
He really did. He spoke out strongly against racism. He got involved in the civil rights movement. He apparently expressed a lot of sympathy for the black people of America, drawing parallels to the discrimination he'd faced as a Jew in Nazi Germany.
That makes sense.
He was also a passionate supporter of Zionism, not necessarily in a political, state-building sense initially, but he saw it as a cultural movement, a way to, as he put it, correct a flagrant wrong and end the pariah status of Jewish people scattered across the world.
And then there was that incredible moment in 1952. They actually offered him the presidency of Israel.
Can you believe it? After the first president, Chaim Weizmann, died, they offered it to Einstein.
What did he say?
He very humbly declined. He basically said he lacked the experience, the people skills to lead a country. He felt his whole life had been about objective matters, and he wanted to spend his remaining years doing physics research.
Sticking to what he knew best. Fair enough.
Yeah.
So eventually his health started to fail. He passed away in April 1955. He was 76. And even his death had a very Einstein quality to it, didn't it?
It really did. He suffered an abdominal aortic aneurysm, basically a burst blood vessel. Doctors offered surgery to try and prolong his life.
And he refused.
He refused. He famously said, "It is tasteless to prolong life artificially. I've done my share. It is time to go. I will do it elegantly."
Wow, I will do it elegantly. He died the next day.
He did, and he had very specific wishes for after his death.
Huh.
He wanted his body cremated and his ashes scattered secretly. He specifically said he didn't want his grave to become a site of pilgrimage. He didn't want to be worshipped.
He wanted the focus to be on his ideas, not the man.
Precisely. But, well, there's a weird twist.
Oh, what happened?
The pathologist who performed the autopsy, a guy named Thomas Harvey, he Well, he stole Einstein's brain.
He what? He stole his brain?
Yep, without permission, kept it for decades, supposedly hoping to study it to find the secrets of genius, cut it into pieces, a whole bizarre side story.
That is incredibly weird. Okay, so ignoring the stolen brain for a second, looking back at everything, what's Einstein's legacy for us today? What does it all mean now?
Well, the scientific legacy is obviously immense and ongoing. His theories aren't just historical artifacts, they're fundamental to how we understand the universe.
And they have practical applications, right? You mentioned solar cells.
Solar cells via the photoelectric effect, yeah. But also things like GPS navigation. Your phone's GPS wouldn't be accurate without accounting for the effects of both special and general relativity time dilation due to satellite speed and weaker gravity higher up.
Huh, I never knew that. GPS relies on relativity.
Absolutely. Lasers, nuclear power, understanding cosmology, black holes, gravitational waves, it all slows directly or indirectly from his work in that miracle year and the decade after.
But it's more than just the equations and the tech, isn't it? It's also his approach.
Definitely. His whole way of thinking. That famous quote, imagination is more important than knowledge. His willingness, his insistence on questioning assumptions, challenging conventional wisdom, that's hugely inspiring.
That ability to just sit and think, the Sitzfleisch.
That legendary focus, yeah. Concentrating on a single problem for hours, days, years even. It encourages deep thinking, critical analysis, exploring totally new avenues even today. Scientists work on alternative theories of gravity, pushing beyond Einstein, inspired by his example of challenging the status quo.
He really did manage to make physics this incredibly complex subject somehow mainstream. He became the face of genius, transformed from, as someone said, a cartoonist's dream come true into the actual word people reach for when they mean smart.
He absolutely did. Synonymous with genius itself.
So wrapping this up, it's been quite a journey, hasn't it? From that curious kid with a compass, through the struggles, the patent office daydreams, the breakthroughs, the global fame, the moral dilemmas. It's a profoundly human story behind the scientific icon.
It really is. We've seen how his unique mind, a mind that literally thought in pictures, dared to just overthrow centuries of physics, gave us this radically new way of seeing space, time, gravity, matter, energy.
Theories that seem so strange at first may be met with skepticism,
but have just been proven right again and again. And they're still shaping our world, our technology, our understanding of the cosmos today.
It really makes you stop and think, doesn't it? If one person's imagination could fundamentally redefine reality like that, what else might be out there? What hidden truths are just waiting, maybe just beyond what we currently think is possible?
Makes you wonder if the next huge breakthrough isn't buried in complex data, but maybe waiting in plain sight.
Right.
If only we could learn to look at things with a different kind of curiosity. Yeah, maybe like a 5-year-old staring, really staring, at a simple compass needle. What are we missing?